Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to derive the derivative of cos x by first principle rule. By first principle rule we have the formula f prime of x is equal to limit del x approaches to 0 f of x plus del x minus f of x whole divided by del x. Since the function f of x is equal to cos x and we have to find the value of f of x plus del x, so we replace x by x plus del x, then f of x plus del x is equal to cos of x plus del x, and then putting both values in equation number 1, we have f prime of x equal to limit del x approaches to 0 cos of x plus del x minus cos of x whole divided by del x. Now if we apply limit, then we have cos x plus 0, cos x minus cos x is equal to 0 divided by del x 0, 0 by 0 form, and to avoid the 0 by 0 form or infinity by infinity form, we use a different methods such as factorization, rationalization, DL aperture, or any substitution to remove 0 by 0 form. As we have a formula cos alpha minus cos beta is equal to minus 2 sine of alpha plus beta by 2 into sine of alpha minus beta by 2. By using this formula on above equation, we have f prime of x is equal to limit del x approaches to 0 minus 2 sine of x plus del x plus x divided by 2 into sine of x plus del x minus x divided by 2 whole divided by del x. Then the limit del x approaches to 0 minus 2 sine of x plus x, 2x plus del x divided by 2, and x cancel by x, we have sine of del x divided by 2 whole divided by del x. Now we see that the function is still in 0 by 0 form because sine 0 equal to 0 divided by 0, so 0 by 0 form. Here we use a relation of limit, that limit x approaches to 0 sine x divided by x is equal to 1. In above equation we see that the sine del x by 2 divided by del x by 2 causes the condition 0 by 0 form, so we apply rule on this function sine del x by 2 divided by del x by 2 form the formula sine x by x. By rearranging, we can divide the del x to sine del x by 2 because we have a nominator, we have a product in the nominator, so sine del x by 2 and division must be del x divided by 2, so multiplying and dividing by 2. Then rearranging, we have limit del x approaches to 0 minus sine of 2x plus del x by 2 and sine of del x by 2 divided by del x by 2, and this 2 comes here, 2 cancel by 2. Then by the rules of limit, we apply the limit on both functions, that is limit del x approaches to 0 minus sine of 2x plus del x by 2 into limit del x approaches to 0 sine del x by 2 divided by del x by 2. So applying limit, we have minus sine of 2x plus 0 divided by 2, and as we have already know that limit x approaches to 0, sine x divided by x is equal to 1. Similarly, if we apply this relation on this equation, limit del x approaches to 0, sine del x by 2 divided by del x by 2, we obtain the value 1. So f prime of x is equal to minus sine of 2x divided by 2, or f prime of x is equal to minus sine of 2 cancel by 2 is equal to minus sine of x. Since the function f of x is equal to cos x and f prime of x is the derivative of cos x, so we can write it as d by dx of cos x is equal to minus sine x, and that is the proof of the derivative of cos x by first principle rule.